Now we will solve problem 2311. This is problem 2311. You can find this problem in Motion in One Dimension, Chapter 2. So, it says, a person throws a ball straight up. I will draw a little diagram for myself. The little ball is thrown straight up. He releases the ball at height 1.75 above the ground. Okay? So this height is 1.75 meters. And with a velocity of 12 meters per second. So he gives it an initial velocity of 12 meters per second. Ignore the effects of air resistance, which means we're working in free fall. How long until the ball reaches its highest point? Okay, so first thing I need to decide on axis. So my number line will be vertical because the motion is vertical. And we've agreed that the best direction, positive direction, is upwards. So this will be my number line. I will name it Y because it's vertical. They didn't tell me where to put my origin, so I can put it wherever I want. And the easiest way is to put it where the ball is thrown. So this will be my origin. Okay, so now I will write what I know. I will go back. I know that the ball is thrown straight up. The initial velocity is positive 12 meters per second because it's upwards, so it's positive. And the initial position is 0 because I took my origin where I threw the ball. Now, the height above the ground is not implemented right now because I'm not studying the ball falling to the ground. It has to wait till I solve B. How high above the ground does the ball go? Okay, what else do I know? They said ignore air resistance. This is free fall, and I know that in free fall the acceleration is 9.8 downwards meters per second squared. So negative 9.8 meters per second squared. And I used 3 significant figures because they gave me 3 significant figures. Now I start thinking about the problem. I write down the formulas that apply. And as I said, these will be given to you in a test. So these are the formulas for motion with constant acceleration that apply. And because our motion is happening on the vertical axis, on the y-axis, I will substitute each x with a y. Each x with a y to avoid confusion. The formulas still apply. I still use the same formulas, but I know that I'm working on the y-axis instead of working on the x-axis. That's all. That's why I'm putting delta y instead of delta x. Okay. So, what do I need to find? I need to find how long. How long? So, I need to find the time. Until the ball reaches its highest point. So, if this is my initial point, my final point will be the highest point the ball can reach. This is the final. And this is the initial. What what's special about that point? At the top, what happens to the ball? At that point, the velocity of the ball is 0 meters per second because the ball reaches this point with a positive velocity, turns around, and goes down. To turn around and change direction, it needs to stop instantaneously. It doesn't mean that it stops and it stays in midair. It stops for a fraction of a second and then moves down. So at the highest point, the velocity is 0. What velocity is it? The initial or the final? It is our final velocity because it's this final point that we're studying in this question. Okay. So, now I look at the formulas. I want to find a formula that will give me the time. So it's either the first one or the second or pardon me, the third or the fourth. It's either the first one or the third one or the fourth. So, let's take a look at the first one. Do I know delta y? I don't. Be careful, girls. Delta y is not the 1.75 meters. Delta y is the displacement between my initial point and my final point. Delta y is the displacement between the initial point and the final point that I'm studying. So this is delta y, and I don't have that. Do I have initial velocity? Yes, I do. Do I have the acceleration? Yes, I do. But I cannot use this formula because I have two variables in it, two unknowns. Let's take a look at the second one. The third. Do I have the final velocity? Yes, I do. Do I have the initial velocity? Yes, I do. Do I have the acceleration? Yes, I do. Wow, great. So I found my formula. I can proceed. I will write it down. It's important to write it on the answer paper. Final velocity, I will substitute 0 equals to positive 12 plus negative 9.8 multiplied by time, which stays as a variable. Okay, so the first step is I subtract 12 from both sides. So my negative 12 equals to negative 9.8 t. Now I divide both sides by the 9.8. So negative 12 is now divided by the 9.8 equals to t. Use your calculators, girls, to find t. The answer is 12 negative divided by 9.8 negative, as we can see, 1.224 and so on. How many significant figures do I use? I use only 3 because I was given 3 in the problem. So 1.22 seconds, and time equals to 1.22 seconds. I examine my answer. It's a positive number. It is logical for a ball to take more than 1 second before it starts going down. So everything about my answer tells me that it's logical, and I accept it. Now let's think about question B. Question B says, how high above the ground does the ball go? So we're still looking at this point. How high above the ground? They still want the maximum height, but above the ground. What they ask for in this question is the whole length above the ground. Okay. Now as I look at the diagram, I realize that this red part is my delta y. And the black part, the origin, is 1.75 meters above the ground. So the total, or the green part, let's call it h. I just made up a symbol. H will be the delta y that I can find from between these 2 points from these formulas, and I just add 1.75 meters to it. So again, they want the height of the highest point, but not from the origin, from the ground. Well, I know that the origin is 1.75 meters above the ground. So if I find how far the highest point is from the origin, I can just add 1.75 and I have my total height. Okay. So which points are we looking at now? We're still looking at point 1 as our initial point, and we're still looking at point 2 as our final point. We're still looking at the same points. So the same values apply. VI still applies, is still 12. The acceleration, of course, is still negative 9.8 because that doesn't change in free fall. And the final point has a velocity of 0 still. And the time to reach that point is 1.22. So I'll scroll down. So here are the formulas. I repeat. The initial velocity is positive 12, still applies. Acceleration is negative 9.8. The final velocity is 0 for the final point because my final point is still on the top, the highest point we can reach. And the time is 1.22. It applies. I can use it. I just found it. I can use it because it is still the same point. Let's take out a look at our formulas. The goal is to find delta y, and from it I will later find the height above the ground. So I will identify the ones that give me delta y. The first one, do I have VI? Yes. Do I have the time? Yes. Do I have the acceleration? Yes. I can use this one. Or the second one, do I have VF? Yes. Initial velocity? Yes. Acceleration? Yes, I can also use this one. And I can even use the third one. Your choice. So you choose which one you want to use. I like to use the one that does not include something that you found. Because what if you made a mistake in number 1? Then you will make a mistake in number 2. But you are free to use any one you want. So I will use the second one. This is the formula I will use. And now I will substitute and I will solve for y. First I got rid of the power. Then I subtract 144 from both sides. And like last time, I divide by 19.6 negative. Girls, use your calculators. You will find that delta y is 7.35 meters. Looks logical. And the total height will be 9.1 meters. That's the height above the ground. Thank you.